Hello everyone, welcome to episode 6 of our beginner series on Unreal Engine 5 and the remaking of Pong. Where we stand at the moment is we have an AI, we have a player, and we have collisions with the ball. If the ball goes past a player, we get goals, we can store our velocity, and we can affect the ball even more. It speeds up, and basically we've got an entire game of Pong. So now it's time for us to edit it slightly, make it a bit more of our own. This time today we're going to add a couple of bit more complicated things. We are going to add a struct, which is going to have all the information on our paddles and the enemy paddles, and we're going to add power-ups, so we're going to expand and contract our paddle. It's going to be a bit more of a longer episode, a bit more complicated things to do, so let's get a crack in here. So the first thing we're going to do is we're going to need to set up a couple of structs. So we're going to need a struct, which is a collection of variables. So you have arrays, which are a collection of a single variable. For example, you can have an array of integers. So you can have dice rolls and you can add them to a array. So it's 1, 2, 3, 4, 5, and 6. That's the only options. Or you can store the current ones you've already done, and 1, 1, 4, 3, and so on. Or you can have a struct, which is a collection of multiple variables. So if we go into our content drawer with control space, go into blueprints and structure, and we're going to call this paddle underscore struct, and we're going to open it up. You can see here we can have variables, we can add multiple variables, and we can change the different kinds of variable as well individually to each other. What we're going to do is we're going to have a paddle struct. It's going to have the actor, it's going to have the size, it's going to have the speed, and it's going to have whether or not it's, let's call it icy, where the lower the amount of friction on the movement. So if we use paddle underscore actor, and we're going to set this to player paddle, and it's going to be an object reference. Add a new one, and we're going to call this size, and we're going to call it a float. This is because we're going to use this as a multiplier rather than actual size. Speed, we're going to keep that as a float as well, and we're going to have icy, and we're going to have that as a true or false boolean. Save that, and next we're going to go into the game mode, and this is where we're going to store all the information for this particular game. So once that loads, okay, it has loaded, and down the bottom here in the variables we're going to create a new variable. We're going to call it player paddle underscore info, and we're going to change the variable type to be paddle struct. Compile and save. We're going to add a new one. It's going to be called enemy paddle underscore info, and because the last one was a paddle struct, it should copy the same across. Compile and save. And what we're going to do next is we're going to go into the paddle. So if we go to our player paddle, if I can find it, here it is, player paddle. And we're going to create a new event on begin play, or event begin play, and we want to get the game mode. We want to cast to our Pong game mode. So we want to grab the variables out of here, and we want to see if this is an enemy paddle. So cast to enemy paddle, and we want that to check this current actor. If it is, then we want to grab enemy paddle info, drag off that and go set members, and on the top right, if you drop down the list of default category, you can change paddle actor, and we can put that into the self. Connect up, And on failed, we want to drag off the Pong GM and go get player paddle info. And exactly the same as what we've done for the enemy, set members in paddle struct, paddle actor, and self. Just tidy things up a little bit. Just make things a little bit easier to read. Perfect. If we open up the content drawer again, and we'll go into our struct we just built, which is, if I can find it, paddle struct, and we want to click on default variables, and I see we want to false, and we want speed and size to be as a 1 as a default, and save. So now we have the variables as the multipliers, but we have no way of changing these variables. So what we're going to do is we're going to create a pickup, and we're going to put it into the world so we can test it. So open up your content browser. We're going to go new blueprint class. We'll call it an actor, and we'll call this pickup underscore BP, and open it up. And what we'll do is we'll give it a cube. Make the cube nice and small. And we're going to give it a box collision, same as what we've done for everything else. So now if we put the item in the world, lift it up a bit, and you'll see that it just stays there in the world. But it doesn't look like a power-up. So what we're going to add is we're going to add a rotating movement component. And just hitting the simulation up here, you can see that it just rotates now. So when we play the game, it should just stay in place but rotate. And just to confirm that we've got it working already, if you go into the Pong ball where all our collision code is, if we just move everything down, give ourselves a bit more space. Off the cast failed and go. Cast to pickup BP. And drag that onto the other actor. And we can just print string. Pickup. So we can just test to see if it works. And by doing that, we're going to add just a few more, so it's unlikely that we're going to miss. Lovely. Now what we can do is just to confirm, we want to destroy the actor, but we're also going to want it to do its thing. So we just wait for the ball to come through, and you see it picks up and destroys the actor. Perfect. So if we go into the pickup BP now, we are going to create a custom event. We're going to call this use pickup. So now we need a way that we can tell this pickup what it is. And the best way of doing that is by using an enumeration or an enum variable. And it's created this very similar way to a struct. So if you right click in the content browser and under blueprints, you have an enumeration selection there. And as it says there, an enumeration is just a list of possibilities. It's just a list, basically. So if we call this pickup type underscore enum, and open it up, we can see we just have a list. So we want speed up, we can have speed down, size up, size down, and ice. Save that, and we will never need that again unless we add more pickups later on down the line. In our pickup BP, we will need to add a variable. We'll call this pickup type. And in the variable type, we want to select pickup type enum. Compile and save, and now on the right hand side we can pick and choose what we want the default for the blueprint to be. If we want every blueprint to be able to be different, we're going to need to select the little I by the variable name, or it's going to be at the top right here, instance editable. And what that does is if we go into the world, we have 4 pickups here, and on the right hand side we now have the option to change the pickup. So I'm going to, by default, I'm going to have them all set to speed up, and we shall work on the speed up first, and then we'll move on to the size. So off of the use pickup event, what we need to do is we need to control and drag the pickup type, drag off of there, and type in switch on pickup type enum. This node is a more advanced branch node. Instead of having true or false, it's going to have an option for each option for the enum. So if you have 20 enums, this branch type node will have 20 different outcomes. So here we're going to want speed up, speed down, size up, size down, and ice. But what we're going to do is we're going to have all of these on the paddle itself, so we don't have to duplicate it, and we're going to have to do anything along those lines. But in order for it to work, we need to reference the paddle that's in question. So we'll work on that one next. So in the pickup BP still, this is under the custom event use pickup, we're going to cast to Pong GM, and off the objects we can get game mode. And at the moment we're going to need to get player paddle info and get enemy paddle info. But we have got no way of deciphering or distinguishing which one is currently in action. Which player is the one that's going to have the pickup affecting them. So for that we're going to go back into the game mode and add a simple boolean. It's going to be player last hit, and it's going to be a boolean. So back to the pickup, and we can have as a game mode get player last hit, and because we want, based on this, we want one of these to do whatever it is happening at the end. We want to scroll down and use a select node. If the player is the last one, we want the player to be true and the enemy to be false. Then we can drag off of here, break the struct, and then we have a reference to the paddle. Perfect. In the player paddle, we're going to create a custom event, and on this one we're going to use speed up pickup, and this is where we're going to set up the pickup to work. We're going to duplicate this multiple times for each pickup, so once you've done one, you understand how to do the rest of them. What we're going to do is we're going to add a timeline, which is a steady change over a period of time. And once that's in, we're going to just double click and add a track. And we're going to add a float track. We're going to call it timeline. Or we can call it change timeline or anything similar. And we want it over half a second. And then we can click shift and click twice in the graph. Make the first one 0, 0, and make the second one 0.5 and 1. Click both these arrows and you can see exactly where it is. Shift and click in the middle and press 1 highlighting all of the nodes, and it smooths out. Have a little fiddle with the handles as well, and it will come up with a nice smooth curve for you. Compile and save, and then we shouldn't need to open that timeline anymore. So a timeline has multiple nodes. An update is every frame it will change, and finish is what happens at the end of the frame. So we're going to want to edit the speed over a period of half a second to get to a max speed. So this is going to be, we're going to need to set our base speed as a variable. So base speed, and we're going to call that a float. Compile, save, and we're going to set that to our max speed, which is currently 600. Compile, save, and we want to get character movement. We want to set max walk speed. And we're going to want a lerp, and it's going to be a float lerp. A lerp is based on an alpha, which is a percentage, in other words 0 to 1. How along that graph, how smoothly is it going to transition? So you want to change the return value to our max walk speed, connect up to our update. We want the base speed, and we want B to go to, let's say, 1.5, which is how, so it's going to be 50% of the max speed based on this timeline over half a second. So from the start, that is. So between 0 and 0.5 seconds, it's going to speed up from 600 to 900 in this case. And then when it's finished, we're going to want to wait a period of time before going back to normal. So we're going to add a new custom event. We're going to call it return to normal speed. And we're going to copy all of this. Apart from, we're going to swap the base speed and the lerp. I've just spotted a mistake, and that is, it's not the base speed to the lerp, it is base speed, and it's going to be multiplied by the lerp. So we want the base speed from 100% to 150%, which is going to be the max speed. So we're just going to copy that one over. And this one's going to be from 150 to 1 based on the alpha. So now we've got one that starts speeding up, and we've got one that speeds it back down. So what we want is, we want to, on this finish line, we want to set timer by event. From the event node, you can drag down onto our new return to normal speed, and we'll set it to 2 seconds. So after 2 seconds, it should go straight back down to normal speed. Compile and save. And what we'll do is, we're going to, on update, we're going to print its max speed as well. So we should see it go from 600 to 900, then back down to 600 for both. It would if we set it up to do that. So in the pickup BP, in the Pong ball with the collision, under pickup BP, we want use pickup. Connect that up. We don't need the print string there because we know it works. So now it should, if it hits a pickup, okay, it didn't. So let's see why. That's because here we are. So that's a pedal actor on speed up. We want speed up pickup. Compile and save. So now go through, you can see it speeds up to 900. 2 seconds later, speeds down to 6. And we can do very similar for the speed down as well. Or we can change this speed pickup, so speed pickup. And we can do exactly the same for the speed down, where we have copy and paste, change it to speed down pickup. And this time, instead of 1 to 1.5, we can have it to 0.5. We're going to change the speed up pickup. So what we can do, or what we can do, is we can take the speed up pickup. We're going to change it to speed pickup in general. We're going to compile and save. Under the pickup BP, we are going to get the game mode. And depending on the player last hit, we're going to grab the size. We're going to set that to 1.5. So we want set members. So on speed up, we want it to set the speed to 1.5. Control D, and we can do that 3 more times. Speed down, size up, size down, and ice. The ice one we want to set icy. The 2 size ones, so size so speed up to be 1.5, speed down to be 0.5, size up to be size 2, size down to be 0.5, and icy to be icy. So if we plug this all in, and then we can do speed pickup, compile and save. And under the player paddle, we're going to change this slightly. So we want to set our game mode as a variable on begin play. I want the speed pickup to change from 1 to get player paddle info, depending on which one it is. So get to the pickup. You want to copy all of this and go back to the paddle and connect all 3 of these. Break. So for the speed pickup, we want the speeds to be there. And we also want it to drop from the speed back to 1. And what we can do is you can copy and paste the whole thing there. Call this size pickup. And then call this back to normal size. We're going to change the size to, the speed, sorry, to size. And we're going to change the lerp to be set actor scale 3D. Quick go in the viewport and we can see where we need to change. So it is on the cube. Make sure the box is attached to the cube. So we want to scale on the Y axis. Get actor scale 3D. Split, split, x of 1, z of 1. Y multiplied by the lerp, give it to y. And we want to do the exact same thing again. Down here. About and save. Back up to pickup. So you want it to go speed pickup there and size pickup for these two. Compile and save. So now if we go to our pickups, we can change a couple of them to size up. Or one to size up, one to size down, but we'll test the size up ones first. Okay, that didn't quite work. Let's have a look why that is. Set speed to set the size to 2. So get the actor Y times 1 to size, so 1 to 2, and it should set that over the course of half a second. Okay, we're going to do very similar to how we've done it with the speed then. So what we're going to do is we're going to get actor 3D. We want the Y, which is 1.25. Call it base size. And we're going to compile so we can read it, and it's going to put 1.25. Drag that in. Put that there, and then we're going to do the same thing under here as well. So size, compile and save, and we shall remove these, and we're going to have one big one in the middle so we can test. Then after 2 seconds, it drops back down in size. Change it to size down, and we'll have another test. So it should, on hitting, lower the size. So you see the enemy now has half the size, and after 2 seconds, it goes back up again. Okay, that was quite a longer episode than usual. So the next episode we're going to be having a random timer to put these power-ups all over the shop with a random power-up. We're going to finish off the ice power-up as well. And we are a couple of episodes away from the final. So yeah, guys, thank you very much for watching. If you liked the video, please hit the like button, subscribe as well, share it away to anyone you know wanting to learn Unreal Engine. Every subscriber helps, especially at the early side of the channel. Join the Discord if you have any other questions. We also accept recommendations for videos or anything like that. But as usual, guys, thank you for watching. Thank you. Bye-bye.